I want to touch on the bigger picture of geometry and why it's studied just for a moment again. Recall that we want to move away from external reasoning through looking at examples to eventually making our own generalizations. So looking at today's material, let's look at a couple of examples. Here we're given a circle O, and we know that T is tangent, TP is tangent. I suppose that could extend on. The radius of the circle is 8. And the tangent segment TP is 6. So now we have to find the length of OP. And remember, you can't trust the diagram that it's drawn to scale, but we do have the postulate that says if a radius is drawn to a tangent, it is perpendicular at that point of tangency. So now we have a 6, 8. If you can't remember, you can factor out the common factor, and then 9 plus 16 is 25. The square root of that is 5. So 2 times 5 is 10. On the second example, we're given that PR and PQ are tangents at O. Tangents of circle O, at R and Q. So I'm going to draw in those radii, and I know that those are perpendicular there. I know that all radii of a circle are congruent, and I also know that OP is going to be congruent to itself by the reflexive property. So here I have right triangles with the hypotenuse congruent and a pair of legs congruent. So I know the two triangles are congruent by HL. I'm given that OR is 5 and OP is 13. So that means PR is 12. And if the two triangles are congruent, that means PQ is 12. Now, let's consider, what if we weren't given 5 and 13? Could we have still made the inference that PR is congruent to PQ?